And what we will talk about right now will be Gloo. So Gloo is an API gateway, and we'll talk a little bit about it. So just a reminder, this is what Solo is doing. We have 3 pillars. One of them is Gloo, which is an API gateway. The other one is Super Gloo, which is a service mesh orchestrator. And the last one is Dr. Gloo, which is a suite of product that extending mesh to different functionality. So let's talk about 1 second what's the problem. Why did we buy it? We built it. So the first one, you all know that, but everybody is running monolithic. They all want to move to microservices. And this is great. Just the only thing that it's mean right now that everything is distributed. Everything is distributed. Network, specifically layer 7, become very, very interesting. So simple question like, how do you manage your API? How can you force security on your organization? How do you make sure that you observe what some, call or request that come into your cluster? This is something that we need to answer. And it's becoming a little bit more complex because don't forget that we also have it multi-cloud, right? It can go all over the place. Same application, right? Just different instances of the application can run in a lot of different places. So that's a very complex problem, and the question is, what are we doing about it? So that's why we build Gloo. The idea of Gloo, again, is to glue those environments. Specifically, if what you want is to ditch your monolithic application and move to your microservices, probably the better way to do this, and this is what you see companies like Lyft or Twitter done, they're not just creating a new team to build the new stuff, because to be honest, you're getting money from the old stuff. They're not just skipping the old stuff, because they really, really need, eventually they do need to move to the future. What they're doing, they're extending the monolithic application by adding microservices features, and on their spare time, they're starting to move. So that's basically where Gloo is really, really strong. So how Gloo is working. So Gloo is an API gateway, but it's really the new generation API gateway. And what it's doing, it's built on top of Envoy. Right? So Envoy is the proxy that eventually is getting the request for the customers. But Envoy is a proxy, and proxy is pretty dumb. It's not going to do anything unless you will tell him what to do. And so E is the data plane, and now you need a very strong control plane. That's exactly what Gloo is, right? So Gloo is reading in Go, Envoy is reading in C++, because you really care about performance on the request part, so you need to make it C++. Again, in the request part, Gloo is not involved whatsoever. The only job for Gloo is to set up the information before the request is coming. And what Gloo is responsible is basically snip up the environment, understand how it should act when a request is coming. So that's basically what you can see here. We also specifically, as part of Gloo, extended Envoi quite a lot, and we will talk about it in a second. So that's kind of like the architecture of how it's really works. So what you have, we basically watching. Gloo is pretty dumb. The only thing that he knows is how to watch. So what does he watch? He's watching the environment, and there is some example, and we'll go more in details. He's watching secret, so Kubernetes secret or Vault secret. And he's also basically watching the configuration of the user. So the configuration of the user can be stored somewhere. It can be files, it can be in Kubernetes CRDs, it can be on console as a storage, right? We don't really care. It's all abstract, and we can extend it to whatever one you want. Now it's watching, and as long as everything is the same, we're not doing anything. But if one thing changes, and it doesn't really matter which, Gloo is immediately detect that. He's getting all this information, but again, he doesn't know much. What he's doing is going to a plugin system. Basically sending it to the plugin system capable of actually translate it to, his part to a language of Envoy, and then Gloo is aggregating it back and sending it to Envoy. Now what's special about Envoy, and that's where the user is requesting, is that also Envoy you can extend. And you can extend it, and this is what's special about it, with filters. So basically, think about what does it mean. Every time that the community of Envoy, and there is a big community on Envoy, we are contributing to Envoy as well as a lot of other like Google and Lyft. Every time that they're adding new features to Envoy, for us to extend Gloo is just to create a very small Go plugin. It's nothing. It's seriously half a day retesting, right? Because everything for us is CI/CD. So the beautiful of it that way, that the reason we actually created Gloo the way like this, everything is abstract. That's kind of like a lesson that I learned when I was working in dynamic op. There's no such a thing, the same data center, customers, their own resources that they're already using, and it's very important that we will, integrate with them very seamlessly. I'm sorry.
Yeah, can I just, I want to make sure I heard that right. As soon as Envoy is extended, you can quickly match that within
Exactly.
a very short amount of time, a day.
Very much. Like for instance, we build our own caching filter, but let's say I'm trying to figure out which filter, I don't know. It's either filter that the environment is building, maybe a Kafka filters. The minute they're offering here, for us, the only thing that we need is basically take a piece of Go, not really long, that basically know how to translate it from the language of Gloo, which is very more friendly, right? Because Envoy is not supposed to be added by a person. It's supposed to be added by machine. That's why it's more complex. So basically what we're doing is just making it easier for the user. So the only thing that the plugin is doing is basically translate it for a very nice API language to a more complex one in Envoi. And yeah, so it's pretty simple. And if you think about it, that means that our API is driven by those plugins. We don't have a set of API. We can always extend it, and nothing should be changed, which I think is pretty awesome. Does that make sense? Mm-hmm. Awesome. So this is kind of like in a nutshell the architecture. So as I said, a huge differentiator for us is the fact that we do care about the environment and the customer. We really build it for customers. And therefore, it was very important to us to discover it all. We believe that our job is to make sure that the user will not going to do any errors in configuration, and we can help him by actually make everything automatic. So we're discovering everything in the infrastructure as a service, whatever you want. And again, it's all plugin, it's all interface, so we can easily extend it to new stuff. Same thing with the services, or whatever services you are interested. And then we're not stopping there. If we're finding it, we're also looking to see if you're either running Swagger, WSDL, GraphQL, or gRPC on top of it. And that's giving us basically, if you think about the signature of this API, right? And that's helping us a lot from a lot of reasons. One of them, we have a transformation filter for Envoy, so we can transform from everything to everything. And we want to make sure that, that way we can know what to transform in the backend. And the second thing is security, right? If I'm getting a request that is a little bit suspicious, I know that's not what should go to the backend. I can stop it there before it's actually coming to the backend. So that's that. And besides that, as I said, server, yes?
How do you check that? I mean, if a request is coming in, how do you check at that point, is it suspicious or not?
So we have a validation, so we have a lot of filters. One of them can be something like WAF filter, for instance, web application firewall that we wrote. So we're using a mod security, so that will be one of example of something that we will detect and say, don't go there. There is a lot of, the beautiful of Envoy is that, not like, if you're using Nginx, for instance, and you're using other companies that are using the API for Nginx, the problem with that is that first Nginx needs to get all the requests, and then the API can say if it's okay or not. That's already can kill it, right? Because it's already took your Nginx, which means it's taking everybody. Forget about the backend, right? So with Envoy, the beautiful of it is that it's streaming, so we can stop it whenever we can. If we see that something is wrong, the message is too big, we're stopping it. And again, because we are filter, we are part of the request. So It's giving us a lot of power.
Exactly. The reason why I asked is because a lot of customers have this concern. That, it's an API gateway, it's letting through all of these things, right. And you do need to allow access to the API, but also want to stop the access if it's malicious or in any way.
Yeah.
So you have to stop it there. So good to know that you're doing that.
Thanks so much. Yeah, no, that's actually really important to us. So.
How is the discovery automated of all these various different components? Do you just point it at a particular environment and say go, or is there more to it?
So it depends. Kubernetes, we can run on Kubernetes, so we just know the services. If you're going to Lambda, you're giving us a credential, and we're going to the API to see which one and discover that. EC2, the same thing. Mm-hmm. It depends, all those EC2 instances and so on. So again, it's all driven by customer request. VMware as an API. So it depends on the platform itself that we interact with. But in the end of the day, again, it's all for us. If you think about what those discovery system is doing, it's a microservices that going and doing and watching and writing the information to a storage that we are watching, right? And the storage can be a CRD, for instance, right? So that's where we basically, it's like a very small binary discovery that can go and communicate to them. And in the, in Swagger, for instance, so the way to do it, if we know when it's actually served, we can be watching there and then using reflection. It depends. Really, that's the right answer.
Okay, so you just need to point it at whatever that particular service is and provide credentials, and it'll walk through that environment and look for
Exactly.
things to add to the list.
Exactly. And then again, something changed in any of those environments, Gloo knows that immediately, can translate, tell this proxy, and we game, right? If it makes sense.
How long does it take to scan an environment? Say I've got an Azure subscription.
So I will show you a demo, you will tell me, you will see. Because I have actually, it's really, really quick. We are really efficient, we know API, right? So we're doing a lot of stuff to make sure that it will be efficient, that it's not going to destroy the API of Amazon, so we're doing a lot of...
And you can configure how often it scans.
Totally.
Okay.
Yeah, and we can also, you can decide that I don't care about to discover the function, I only want to discover the instance. That's fine, it's your choice. It's kind of like a flag, so you can choose what you want to do.
Okay.
Make sense? Cool. Yeah. Cool. Awesome. And also, as I said, it's very important to us to run wherever we want. So basically what you're reading out here is that we're running wherever you want. So that's some of example, right? But basically, again, it's all based customer request. We persist, right? Because that's a very important piece. We persist wherever you want. And this is very interesting because, for instance, if we are running in Kubernetes, that means that you can use CRD, which means that you don't need as a customer to use active Cassandra cluster. That's a big, big reason that customer is coming to us because no one wants to do active Cassandra cluster. So I think this is kind of like one of the advantages we have. And as you can see, if you're using, if you want an environment that is Ashy stack, for instance, you don't want any Kubernetes. So I showed a demo in HashiCom last week, 2 weeks ago, that you basically can run on NodeMed, watch, store in console, discover from console, and basically watch also the secret of vault. So it's all kind of like Ashy stack. You don't need Kubernetes if you don't want it. But again, then you don't need to. If you already back up console, you're basically getting us for free, right? You don't need to take care of our storage. So that's really, really important. As I said, we will meet the customer where they are. And this is, I think, one of the way we build this platform, that it's really important that it will be so that way that we can actually give it to the customer as tailor-made. And this is the reason we are running accounts, because they're coming to us and they're asking what they want, and immediately we can give them exactly what they want tailor-made. And I think this is a big advantage. And the last one, as I said, is secret. So we are watching the secret every time that the secret are doing rotation, we're detecting it, we're sending it. So that way, on the request part, we can and create a connection and so on. You as a customer does not need to worry about that. So again, now we'll talk a little bit about the design principle, unless it's all good, no question, right?
Here's a little more detail about the secrets management and how you're handling that, because secrets are one of the more difficult things to get right.
Yeah.
And it's really bad if you get it wrong.
Right. So a lot of the customer is just using a Kubernetes secret, right? And it depends when you need them or when no. There is we're using, maybe you want to talk about it a little bit more, the account
Service accounts?
Yeah.
So first of all, Gloo isn't managing the secrets per se. We offload that to Vault or to some other piece of infrastructure. But what we do is we pull them in, and we're able to match those up with the various backends that we're calling and certificates that we're presenting on the ingress level. So we don't have a secret management component to this, other than just using what customers already have.
Okay.
Yeah. So for instance, for Lambda, this is one that we're doing interesting. We are watching the secret every time that it's changing. On the request part, when it's coming, we're already creating the signature, putting it in there, they're creating the signature directly with AWS and calling it. And we have customer that actually said that that's become, actually, it's faster than use the regular AWS API gateway. I don't know why. They do it, but it's actually because we wrote on the C++ library. It's way faster. So it's just an interesting, and we were actually really surprised about that.
Pretty damn slick, I gotta say. I just gotta say.
Yeah.
That's
So I will show you. So I will show you soon a demo. Hopefully you will like it. And there is also a lot of crazy requests from customer. I mean, so we are doing really interesting stuff on secret and security in general.
I think you just cleared a lot up, I think, with that statement. Does that make sense?
What's that?
For me. Anyway. Because you're literally watching the message bus. I mean, you're literally in line.
I'm there.
And you're taking predictive measures against every request you see coming through. So you're making
decisions
based on that.
Exactly. And this is really powerful because we own the network,
absolutely.
basically, right?
Absolutely.
Which is really good. So just the design kind of like principle, as I said, we want to make it very, very easy. That's where we talked about the first slide, if you remember, is that it's very important as the people will be able to actually use it. It's not only an open source project for fun. And therefore, if we're running, for instance, on Kubernetes, we're leveraging everything that it's giving us. So we're storing there. Everything is a declarative API. So seriously, if you look at the Gloo code, it will ring a bell for you if you ever looked in the Kubernetes one or in STO one, because to be fair, this is the way we're working. It's really, really exciting in terms of the declarative API. We're acting as a Kubernetes ingress in case you want, and you don't feel to have all those functionality. Always in sync, and this is very important. So I mean, it will be eventually consistent, but it will be consistent. And then the last one is that we're leveraging a lot of stuff. Like for instance, for load balancing, we're using the pod label and so on. So we're really, really trying to get this information and said, well, how can we help the customer? How can we understand without him telling us? So that's that. Why Envoy? I don't know if you're familiar with Envoy, but I will still going to say that Envoy is by far the best proxy that exists there, and I don't have a skin in the game. It's just really the one that is the strongest. There is a few things that attract me when I started the project, and I wanted to actually choose. The first one is performance, okay? So it's really important, and there is a killer performance to it. So when our customer are doing that versus a lot of the others, API, it's not a problem whatsoever, and it's really performance. Extensibility is really, really important. I want to be on this bus.
Right.
I don't want to be outside and then I want to be inside and be able to stop and fix and do all of this stuff. And therefore, the extensibility with the filter was really, really strong feature for Envoy. We are doing tons of filter for it. It's C++ async, it's not easy. It's soon we're working with, Google is going to add also WebAssembly, so we'll be able to kind of do it in different language, but that's our differentiator, and that's why we chose that, because we can differentiate ourselves by that. In terms of community, so we chose it, we're contributing a lot, but there's also Lyft, and there is Google, and there's Apple, and there's all the others. So it's great, right? So we're building it as a community. And the other one is an API. So not like Nginx, where you basically need to put the file and do an auth restores. It's API driven. You can form the FAR. So basically, the right approach to use Envoy is to have a control plane that actually configure multiple data plane, right? And this is very important. And the last one is migration. So as I said, when we started the company, what I wanted is to help people migrate from monolithic to microservice. Guess what? The reason Envoy actually was created wasn't because service mesh. It was because Lyft needed to migrate between monolithic to microservices. So that is a perfect use case for this proxy. And as I said, we talk about it's open source, which is great. You can go look at the code, and trust me, it's really, really good one. The discovery is very strong. Storage, as I said, abstract. You can choose your own plugins, and all of this is what make us give the customer tell us it's a made solution, and that is our power. You can't believe, I can show you tons of emails from the customer. We can't believe you do it so fast. Doing so fast because it's pluggable, right? We don't need to change anything in the system. Awesome. And as I said, security. I mean, to be honest, we build it, and today, if we're adding feature, usually is driven by customer, right? They request, and we're adding. So we have a lot of integration with everything that exists there in all those levels. It's all very, very efficient on the request path and so on. So again, it's just really, really important. And we're integrating with other stuff. As we said, service mesh, right? This is the right one that we need to integrate with this. Most of the service mesh doesn't have a gateway, actually. And also, they shouldn't, just to be fair, because service mesh is fixing a problem between what's called east-west traffic. It should be totally different than what you're doing when you're coming from north to south to the cluster. And the reason is because you don't know who's coming. It's not my service talking to my service. It's someone that I don't know is trying to get to my business. And I need to make sure that it's way more protected. It should be different. So we believe that there should be this abstraction, but we should believe that it should work seamlessly together. And that's what we did. For instance, in STO, what we have done is we basically make sure to talk to the SDS and make sure that we're getting the same root certificate. And that way, you don't need to have two sidecar in order to work when you're working with Gloo. It's our sidecar proxy is talking directly to theirs, which means that it's way more performance. So performance is very important to us. Besides that, serverless, we talked about security, we talked about it, and also CI/CD, it's very important. Today, most of those rules are not done by YAML files. They are, but I mean, they're driven by someone pushing something to a GitOps and basically doing all this process. So it's very important to us to play there as well. The last one that I will talk, I think, is this is actually really interesting integration for us. So when Knative, which is the serverless for STO, for Envoi, for Kubernetes, coming from the Google guys, when they actually announced it, the idea was to give kind of like the PaaS experience serverless on top of Kubernetes. When they put it out there as an open source project, it was depending specifically on STO. That was a problem to the most of the community because, to be honest, it doesn't need a service mesh. All it needs is an ingress, basically. And it's like, I don't know, I'm asking you to clean the room and you're going and you destroy it. And then you say, it's clean. It's not clean, right? You shouldn't do that. It's overkill. So when Google figured it out, they actually did the research and they came to us and said, look, we actually need an API gateway because we're getting a huge pushback from the community. We would love to put yours, and that's exactly what happened. So basically, we integrated that. We're running on their CI/CD, and we are so lucky and that Google recognized that our solution is the best. We are running inside their CI/CD. Every feature that you can get with STO and Knative, you can get with Gloo with no exception, and that's really, really important. And that's the feature of Gloo, and that's in the website or in everywhere else, but just you will know, we're supporting everything, and again, daily, it's added more and more and more because of the architecture. And now, if you're all okay, I will show you a demo. So this is an application. It's a very simple application. It's what called this test application for Spring. It's really a low word for Spring application. It's actually not even written by us. It's written by Pivotal. So I can show you here. It's basically the Pivotal code, Pivotal people, and it's a Spring application, which means that it's a monolithic application, complex like you can imagine, right? And it's all great, and it's working, right? I mean, it's working pretty good. What you can see is that I can browse it. It's written in Java, and it's pretty awesome. But when you're coming here, I have a new engineer in my team, and I extremely want him to add a new column for the location of the vet. What does it mean that you need to do today? So let's think. The first thing that you need to do, you need to learn the monolithic application. That's already a pretty bummer. Then you need to actually add the functionality. Then you need to test the functionality. Then you need to regression test to see that it didn't break anything else. Then you need to redeploy monolithic application. So what I did instead is I wrote a very, very small Go code here. Seriously, one underline, as you can see, that's going directly to the database that the monolithic application is using, getting the information that it needs, and running an HTML page. That's all it's doing, as you see, 100 line. That's it. So now let's see how Gloo can help us. So this is the UI of Gloo. Maybe let's do it like this. OK, so this is the UI of Gloo. And what you can see immediately is that you're getting some information about your environment. So what you can see is that I am having one proxy of Envoi, and it's green, it's happy, right? This is actually very, very interesting, and I will explain why it's very important, what I'm showing right now. Besides that, I have the upstream. Upstream is basically the discovery of the environment. And what you can see is that I have Kubernetes services, I have some static services, and I have also a problem with one of them, as you can see. So we can go 1 second and see. If I will click on this, you will see that it will show me that I have a reject, and it will tell me what it is. The reason it's happening because I just trashed data there to show you that it's failed, right? And of course, I can see all the upstream that exist. I can see them this way. I can see them that way, and then basically open it. You can see that they are green, which means that they are healthy. And we can go to see one that is red, which means that it's not good, right? And it's pretty simple. It's discovery. It's pretty, pretty simple. The other thing that you can see here is that there is also virtual service. And virtual service is basically the application that you're creating, right? That you're building from the routes. So what you can see is that I have two that here. I can go. I can see it in this way. Or I can see it in this way. And basically, I can click in. Again, you see everything. This indication is that it's green. It means that it's healthy. And I can come here, and I can see that basically this is the monolithic application, right? This is the monolithic application, and everything is routed to it. It's pretty simple. I can also configure it with external auth or rate limiting or anything else that I basically wanted to do this. It's pretty simple. Now, why it's important, this piece with Envoi. And this is something that's really, really important specifically to me. Envoi, you need to be a contributor to Envoi to know those stuff, right? But here's the thing. Envoi has this beautiful feature that when I'm giving him a configuration, he's usually actually pretty happy. Even, like, unless there is syntax error. Even if the configuration that he got doesn't make any sense to the environment that he's looking at. Why is that? Because it's all about eventually consistency. So he's feeling comfortable with that. But here's the thing. So I just gave him right now a security change. And he told me everything is great, but he's never serving it. He's only going to serve it when the environment will be ready for it. So you think you just changed your security, but actually you didn't. We're detecting it, and we are the only one who's detecting it. And this is really, really important because, again, you need to be a contributor to Envoy to understand this stuff in order to understand that that's, it's a feature, it's not a bug, but you need to know about it and detect. And that's what you can see here. We're basically detecting it, and we're saying there is, it's healthy. If it will not be healthy, we will tell you that. So now the only thing that I will do real quick, because I think we're running out of time, is that we will go right now and look at the pet clinic. And you will see that I have 4 instances. The first one is the monolithic application. The 2 other is a database. And the last one is basically the Go microservices that I just put on the server, on the Kubernetes. You see all of them in Kubernetes only because I took lift and shift the monolithic one. So what we're going to do right now, it's pretty simple. I will come here and I basically, just mess it up. I'm going to basically edit, and it's pretty simple. I will say, I want you to add it to the default application. This is the one I want you to add. And every time that something is doing /vet as a prefix, I want you to basically route to it. So that's pretty simple. And you see it's happened, and you see it's green, and we will go back right now, and what you see is that this is still the Java, but this is the Go microservices, right? It's pretty simple. But what you can see that also contact is not working, and that's pretty annoying. So what we're going to do right now, instead of me asking my engineer to fix it, we will put a Lambda. Every time that someone is coming to this page, we will spin up a Lambda. So how are we going to do this? We will go to Gloo. We'll come back here to the upstream, and we will add an upstream. So we're going to call it, let's just say AWS. We said that it's AWS side, and now the only thing we actually need is to put the secret, and we're adding it. So you ask about you saw how quick it is? That's how quick it is. Now look at this. It's already found me all the Lambdas. Okay. Pretty fast, right? Everything there, trust me, like go look. It's like we're putting a lot of attention on this. So you find all the Lambda that run under it. So now what I'm going to do is pretty simple. We'll go again to the virtual service. We'll go here. We will add a new one. We know where it is going. We will say go to AWS, find all the function. Let's run contact form tree. Now Lambda is always returning JSON, but I really want here HTML. So we will use our transformation filter, and I'm going to enable it.
So all those Lambda functions are functions you have already created in AWS in the account that you are accessing through this.
And I can.
So it's not like loading those functions, it's just discovering.
We can do that if we want, but we didn't have done that.
And now you're telling the application when you go to a particular path,
use this function.
Spinning it up.
Spin it up to this function instead. Return whatever that function does. Okay.
And we can transform it like I'm doing right now,
Which
right?
means you're kicking off that function before it.
Exactly.
So if you want to
it's automatically faster than if you were just to go.
Exactly.
Right.
And it can only discover the functions that are associated with the key that you pass.
Exactly. Of course, right? That's dangerous. So I'm just saying every time that it's going to contact flip as a prefix, please go and spin it up. In a second, it will start. And what we'll do right now, we'll go back to the application, and we'll see that this is still a Java application, right? This is a Go microservices, and every time that I'm clicking contact, this is the Node.js function in AWS. Do you see how speed it is? Again, we really, really care about speed here. Mm-hmm. So that's basically in the nutshell. Does that make sense?
That wasn't fast enough.
So who? So who actually is the intended user of the interface? Is it the dev team? Is it an ops team? Is it a security team?
Yeah. So we have a lot of options, but a lot of different users. There is a user. A lot of them are the architecture owners, API manager in charge, and so on. But there's a lot of also startup that just coming, and there are small customers that are coming. They not probably using UI. They're just going YAML file, putting it as part of their CI/CD and so on. So it really depends. That's the real answer. But we have also really, really big customers. They have to have the UI.
And it could be integrated with GitLab, GitHub.
Yeah. So I mean, actually, that's not yet. But yeah, it's coming up very, very soon. So everything that you will do here is actually going to go on your behalf, checked it in. On your behalf to a branch, and then only after approval, it will go to Gloo, which means that you can getting rollback, security, compliance, versioning, all of this.
Yeah.
And if you have a customer that already has that's running like AWS API Gateway, you would use Envoy to shim into it, or how would you leverage?
So we have some customers that are running, for instance, product like Apogee, and they're using it for the external API. We are also going to have that very soon, but we are more kind of like, we're not a dev portal yet. And then basically what they're doing, they're going to just basically send it to us, right? So basically they will route to us, and we will make, but the logic will be with us.
Cool. So with
AWS
API Gateway specifically, that, and a lot of our customers are running in Kubernetes and so on. API Gateway runs in its own managed area of AWS.
Right.
To connect it up to Kubernetes, you have to do a little bit of massaging, exposing VPC links and private stuff, private links. And then once the traffic gets to Kubernetes, you still need something that can understand how to route inside of Kubernetes. And so we have people that we're working with that are going to use Gloo inside of Kubernetes after the API gateway.
So basically,
So the other piece of this, that because you guys are showing a very container and in one case, functions-based use case for this, but hence the name of Gloo. Kubernetes doesn't have to be involved in this scenario at all. This could all be monolithic applications.
Totally.
Correct.
And you're just using this to be able to build microservices to attach to any monolithic application.
Exactly.
Just as long as I'm using Envoy as the bus.
That's correct.
Exactly.
Yep.
It's just a better API gateway. So, in that case, if you're not running Kubernetes, it would be exactly like Apogee and the others. It's just better performance. It's going to give you nice interfaces. It will discover everything. It will not create a lot of the stuff. So that's the point. Yeah. And the last thing that I would say, because I'm really, really up for time, is that we also have an admin, which I think is pretty cool. So this is our representation inside. And we're actually propagating it up for you guys to be able to actually, and everything eventually is a YAML. So we will go to one of them, for instance, here. You will see that it's translated to a YAML. You can download the YAML and so on. So this is also something that is very important to us, because in nutshell, a lot of our users are actually very advanced, and we want to make sure that they will not need to deal with UI a lot.
One thing that I think is important that we're doing is that it's different from a traditional, more centralized or monolithic API gateway, is that our API at the YAML level, at least, allows an operator to delegate part of the definitions of the routing for a particular application. So the application teams and the owners of those applications can own that and include that as part of their source code. And when that gets checked in, that can go through CI/CD and so on and get merged into and tested against the API gateway. But it reduces some of the friction between development teams now needing to coordinate and synchronize with a centralized API management team to get something changed. For example, routing or header matching or prefix rewriting or something like that. And that kind of decentralizes some of that.